production line is impressive for its efficient, large-scale conversion of coconuts into diverse products using a blend of traditional methods and intricacies of these production lines, and delve deeper how these factories work, then you can... Coconuts are harvested for large-scale processing primarily in tropical countries such as the Philippines, Indonesia, India, Sri Lanka, and Thailand. These countries manage coconut plantations with regular weeding, fertilization, and pest control to maintain healthy trees. Harvesting is typically done manually by skilled climbers using ropes or cutting tools, although mechanical methods like hydraulic lifts are also used in advanced plantations. In regions where coconut plantations are located near rivers, massive quantities of coconuts are often transported to processing factories via boats. The boats travel directly to the factory piers, where they dock and unload their cargo. At the factory pier, the coconuts are offloaded using cranes, conveyors, or manual labor, depending on the size and equipment of the facility. This direct delivery system minimizes handling and transportation time, ensuring that the coconuts reach the processing facility quickly and in good condition. Large quantities of coconuts are efficiently managed using a combination of conveyors and manual labor. Workers are stationed along these conveyors to inspect and sort the coconuts, removing any that are damaged or do not meet quality standards. This initial sorting ensures that only high-quality coconuts proceed to the next stages of processing. The conveyors then transport the sorted coconuts to various processing areas within the facility, where they undergo dehusking, deshelling, and further processing into products like coconut oil, milk, and water. After the coconut flesh is extracted, it is first manually cleaned by workers who remove any remaining husk fibers, shell fragments, and impurities. This initial cleaning ensures that the flesh is free of major contaminants before it undergoes further processing. The manually cleaned coconut flesh is then placed on conveyor belts and transported to automated washing stations. Here, high-pressure sprays thoroughly clean the flesh, removing any finer impurities and ensuring a high level of hygiene. After the washing stage, the flesh may undergo blanching, where it is briefly immersed in hot water or steam to sanitize it and deactivate spoilage-causing enzymes. The clean flesh is then shredded or grated into smaller pieces using specialized machines, producing either fine shreds for desiccated coconut or larger chunks depending on the product requirements. For coconut milk and oil production, the shredded flesh is mechanically pressed using hydraulic or screw presses to extract the milk or cream, which is then further processed to separate the oil. For producing desiccated coconut, the flesh is typically shredded or grated into fine pieces. However, to produce coconut chips, the flesh is sliced into larger, thin pieces. The shredded flesh is dried to a low moisture content to extend shelf life while retaining its flavor and nutritional value. For coconut chips, the slices are dried until they achieve a crisp texture. The drying process is carefully controlled to ensure consistent quality and prevent over-drying or under-drying. The The packaging process for coconut milk and water involves a highly automated system designed to handle large volumes efficiently while maintaining product quality. After extraction and processing, the coconut milk or water is pumped into automated filling machines equipped with multiple heads to fill hundreds of cans, bottles, or cartons simultaneously, ensuring precise volume consistency. The filled containers then move along conveyor belts to sealing machines, where cans are sealed with seamers, bottles are capped, and cartons are folded and sealed securely. Automated labeling machines then apply labels accurately, detailing product information, nutritional facts, barcodes, and expiration dates. Sealed and labeled containers are grouped and placed into boxes or crates by automated case packers, configured for various packaging needs like 6-packs, 12-packs, or bulk cases. These boxes are then stacked onto pallets by automated palletizers, wrapped with stretch film for protection, and labeled for shipping. The process of making natural organic coconut sugar is quite different. It is done with harvesting the sap from coconut palm trees. To extract the sap, skilled harvesters climb the coconut trees using special knives and cutting tools. Once the incisions are made, the sap slowly drips from the cut flower stalks into collection containers, usually attached to the tree. The coconut sap undergoes a heating and evaporation process to remove excess moisture, resulting in a thick, syrup-like consistency. This concentrated sap is then cooled and stirred until it crystallizes into granules, forming natural organic coconut sugar. After the coconut sap has been heated and crystallized into sugar, it is transported to a factory for final processing and distribution. The crystallized coconut sugar is first sifted to ensure uniform granule size and to remove any impurities. It is then weighed and packed using automated packaging machines into bags, jars, or bulk containers, depending on the distribution requirements. This efficient and large-scale process transforms coconuts into a diverse array of products, meeting global demand with high standards of quality and sustainability. The industry's ability to integrate natural methods with modern technology highlights its significance and innovation in the of kombucha has driven the rapid expansion of large-scale production, revealing a journey of meticulous brewing to meet the growing demand. In the initial stage of kombucha production, the factory sources high-quality tea leaves, commonly black or green tea varieties, from reputable suppliers. These tea leaves serve as the primary substrate for fermentation, imparting distinct flavors and nutrients to the final product. Utilizing stainless steel tanks or kettles, the factory brews the tea on a large scale, optimizing efficiency while maintaining strict hygiene standards. The tea leaves are added to the brewing vessels and then it is steeped to extract its aromatic compounds and beneficial components, resulting in a flavorful infusion. To provide fermentable sugars necessary for the SCOBY's metabolic activity, precisely measured amounts of sugar are incorporated into the hot tea, ensuring a balanced and consistent brewing environment. This sugar serves as the primary substrate for fermentation, fueling the SCOBY's transformation of the tea into kombucha. The factory proceeds to cool the sweetened tea mixture to room temperature, a critical step in preparing it for fermentation. This controlled cooling prevents thermal shock to the delicate microbial ecosystem within the tea and ensures optimal conditions for subsequent fermentation stages. Once cooled, the tea is carefully transferred into specialized fermentation tanks, each designed to facilitate the microbial transformation of the tea into kombucha on a large scale. To initiate fermentation and establish the desired microbial community, additional filtered water is introduced into the tanks, adjusting the concentration of the tea mixture to the desired level. Furthermore, starter liquid from a previous batch of kombucha, rich in established cultures of bacteria and yeast, is added to the tanks. This serves multiple purposes. It kickstarts fermentation by introducing active microbial populations, lowers the pH of the mixture to inhibit harmful pathogens, and fosters the growth of beneficial bacteria and yeast, essential for the fermentation process. The fermentation tanks or containers are sealed to prevent contamination and maintain optimal conditions for fermentation. These conditions typically include a controlled temperature range, around 75 to 85 Fahrenheit, and limited exposure to light. The kombucha ferments for a predetermined period, typically between 7 to 14 days, although this can vary depending on the desired flavor profile and production schedule. During fermentation, the SCOBY consumes the sugars in the tea, producing organic acids, carbon dioxide, and trace amounts of alcohol. This process imparts the characteristic tangy. After fermentation is complete, the kombucha undergoes filtration to remove any remaining solids, yeast sediment, or SCOBY fragments. This helps clarify the liquid and improve its appearance. Flavorings such as fruit juices, herbs, or spices may be added to the kombucha at this stage to create flavored varieties. These ingredients are carefully measured and mixed according to specific recipes. Prior to bottling, the factory implements stringent sanitation protocols to ensure the integrity and safety of the final product. Glass or PET plastic bottles, chosen for their durability and inert properties, are thoroughly sanitized to eliminate any potential contaminants. This meticulous cleaning process helps maintain the kombucha's freshness and prevents microbial spoilage during storage and transportation. Once sanitized, the bottles are filled with the filtered and flavored kombucha using precision machinery, minimizing exposure to external elements. To provide consumers with essential product information and branding, labels are meticulously applied to the bottles. These labels contain pertinent details such as product name, ingredients, nutritional information, expiration date, and branding elements, serving as a means of communication between the producer and the consumer. In large-scale kombucha production facilities, bottling is a highly automated process that efficiently handles thousands of bottles per day. The bottles are then conveyed on a continuous production line to the filling station, where automated filling machines accurately dispense the desired amount of kombucha into each bottle. These filling machines are equipped with multiple heads to handle several bottles simultaneously, optimizing throughput. Once filled, bottles move to the capping station where automated capping machines securely apply caps or lids. After labeling and inspection, bottles are grouped into cases or trays by automated packaging machines, then palletized and prepared for shipping. This seamless integration of automated machinery and quality control measures allows kombucha producers to meet market demand efficiently while maintaining product integrity and consistency. The cases are transferred to distribution centers where they are organized for transport to retail outlets or other destinations. Automated systems and logistics software play a crucial role in managing inventory and coordinating shipments. Palletized cases are loaded onto trucks or shipping containers, optimizing space and ensuring efficient transport. Distribution centers act as hubs for coordinating deliveries to various retail locations, ensuring timely and accurate fulfillment of orders. Kombucha has become a widely enjoyed beverage in modern times, appreciated for its unique flavor profiles, potential health benefits, and versatility. Consumers have embraced kombucha not only for its refreshing taste, but also for its probiotic properties, which are believed to support digestive health and overall well-being. Kombucha is enjoyed in various ways, from sipping it chilled as a standalone beverage to incorporating it into cocktails, mocktails, or flavored mixes. If you want to witness the fascinating